at explaining some of the concept of distributed computing and how it relates to big data. And then we gave a broad overview of the as part of the lesson objective, for the technologies for handling big data is to look at the distributed computing technology, parallel computing technology, and how it relates to big data. Then having a broad overview of Hadoop technology itself. Hadoop is something that has always been, it was the Yahoo guys, it was the Yahoo boys during their PhD. They were the guys that actually invented Hadoop technology. But because after a while, what some of those companies do after a while is that their technology, after they've used it for a very long time, they just release it to the public. And the same is happening with TensorFlow framework. Google have had it for a very long time, but Google then also after a while now release it, maybe 3 years ago or 4 years ago, released it to the public. So now everybody's talking about TensorFlow framework, but those things have actually always been. There are also some technologies that are currently in vogue now. That we are already interacting with them on Google platform, but we don't know about them. After a while, they just release it to the public for us to see. So I'm joining the class on another platform, and I will share my screen. So yesterday we talked about the distributed computing and parallel computing. We talked about the difference between distributed computing and parallel computing, where we said that the distributed computing system is a collection of independent computers that are interconnected to accomplish a particular task. So I was also thinking, what is, if there's a better way I could explain that concept? And I indeed have a better way I can explain the concept. So look at so yesterday I said that in computing generally, there are 3 key resources that we try to manage in computing. One of them is the processor. The processor determines the speed of execution of a job. So number 1 is processor. Number 2 is the memory, the memory space. The memory is the real location where the job is done. So if memory is the real location where the job is done in the computer. So there is processor. Processor is what gets the job done, but memory is the space that is available for getting the job done. And then there is storage. Storage is where you store the data after the job is completed. It's where you store the data where the user can access the data. So let's say we want to send 60 people to Abuja, for instance. We want to send 60 people to Abuja. There are 2 ways. There is one BRT bus, and there's a BRT bus, and there is a car. So if for those 60 people, if we want to, if it's only one car that is available to take those 60 people to Abuja, it means that car will probably have to go like maybe if the capacity of the car is 5 passengers, that means the car will probably have to go like 12 times or more than 12 times before it can take everybody to Abuja. So when you look at the car going to Abuja, and comparatively now, there's a bus that's also taking people to Abuja. A BRT bus has like up to 60-man capacity. So the car may seem faster, but at the end of the day, the BRT bus, even though it is slower, it looks like it's much more efficient. But now, if we can now have, for instance, 12 cars, if we can provide like 12 cars, for instance, it actually means that we would get people to Abuja faster than how we get people to Abuja with a single bus. So that is the whole concept. That is the whole essence of distributed computing. So there's a job that needs to be done. Instead of asking only one bus to do the job, or instead of asking one car to do the job, why not look for many smaller tasks and connect them together in a way that they will get the job and split the job among them. Am I on hold? Yes, I think I'm on hold. Can you guys hear me? So that it will not be like yesterday that I was talking to myself.
Yes, I can hear you.
Okay, thank you. All right. So yes. So as I was saying, yes, distributed computing split the job into a number of tasks among independent computer systems. While parallel computing it's a bit like the way when you see a train, a train has many different coaches. It has many different coaches. So we can assume those coaches are the processor. For instance, I'm just using that as an example. Assuming that the coaches are the processor and the engine is the memory, for instance. So the concept about memory, parallel computing is there are multiple processors and there is just one memory, and the task, even though it's executed by multiple processors, but they share a common memory space to get the job done. So those are some of the things that we discussed yesterday. So we are going to continue on that, and I took time to explain the architecture of. I took time to explain this architecture. Please, if you can see my screen, just let me know that you can see my screen. Can you see my screen? Please, can you confirm if you can see my screen?
No, I can't see your screen.
Okay, so yeah, so what's going on here? I think I'm in the wrong class. Petra, is Petra in this class? Yes, Petra is here. Okay, so I think I'm in the wrong class. Just a minute. Let me get to the right class. I think I'm in the wrong class. That is for the screen that is sharing. It's in the wrong class. Saturday. I don't know how to do this. Today is Saturday, 2 p.m. So please, can someone invite me again? Can someone send a call to me? Try to invite me to the call the way you did the other time. It's someone doing that for me. What's going on? Yes, correct. Thank you. Yeah, so this works. Okay. Sorry about that. Okay, so I'm sharing my screen now. Okay, so I took time to explain this architecture to us yesterday, and it's also what I have just explained this afternoon. So distributed computing involves many independent but interdependent computers that are working together in a coordinated way, while parallel systems are made up of multiple processor, but they share a common memory. So today, let's look at how complex data analysis job will be done either in a parallel computing environment or in a distributed computing environment. This is also very similar to what we also do, like in our everyday life. If you have a complex job to do, like that involves a lot of tasks. So first thing that we try to do is to break up the job into smaller parts. So if you want to build a house, for instance, there'll be some people that are doing the digging of the ground, while some people are mixing the cement, while some people are mixing the sand. Just the concept of division of labor in economics, for those that study economics in the house, so it's the same that also applies in computing. And again, computer is just computing, or computer science is small. It's the economics of, this is my definition now, it's the economics of memory, processor, and storage. Yeah, this is my own definition, and this is my own economics definition of computing. It's actually the economics of processor, of memory, and storage space. That is what we try to juggle together most of the time. So in this case, if there's a complex job that needs to be done, it's broken down into smaller parts. And look at, again, I'll be using a lot of that 60 people traveling to Abuja example. So if 60 people are traveling to Abuja, we may want to get all the job done at once by putting all of them in a bus. But of course, that is going to be slow. If you put them in a BRT bus, it's going to go slower until they eventually get to Abuja. But if you can split them into smaller, which also means the implication of that is that if the bus also breaks down at Okene, it means that all of the job will be stalled until the bus is completely fixed. But if in another way that can be done is to take all those 60 people and split them into smaller unit of vehicles, into some saloon cars, and then get them on the road. So even if a car breaks down on the road, you can be sure that at least for those that their car is not broken down, they're still going to get to the destination. So it's that same economics that is applied in computing and in big data processing environment. And the idea is to exploit the hardware in order to compute, in order to execute complex jobs. So number one step you need to take in trying to do that is to break the job into smaller parts. Then you now survey, identify all the computing process resources that are available to execute the job, and then you now assign all the smaller tasks that you have divided into smaller units. You now assign them to the different computing resources that are available. It's just as simple as that. So if we go back to this previous, to this image, for instance, so if there's a job that needs to be done within this distributed computing environment, we can split. Is it possible to split that job into smaller units, into smaller tasks, and assign each of those tasks into each of these processing units, the processor and the memory? So each of these is a computer actually. So assign the job to each of these computers, and they get it done, and then the result is combined together and is returned back to. The result is combined together and is returned back to the requester of the job. That's the whole idea around the distributed computing. Now, but that is not without a problem. And the problem to that, to this concept, the problem to this concept is the problem of latency. So at times the job can indeed be, there can be slowing down of job because of So again, how computer works is, I'll come back to this diagram. As I said yesterday, if we were in the classroom, maybe I would be drawing some diagrams on the board. So how computer works is that if there's a job that needs to be done, so the job goes between the disk. So assuming that there's a disk drive somewhere, the job goes from the disk, the processor goes to the disk and takes that job and put it in memory and execute it in memory, and the processor goes again and takes the job from memory and write it back to the disk. So usually there's always a lot of back and forth. There's always a back and forth between the processor and the memory and the disk. So classical real life example that I can use to explain this is your ATM. So ATM network for First Bank, for instance, is a distributed computing network. So you imagine that there's only one ATM in Lagos State, and maybe 100 people want to withdraw money from that ATM. You know, what it means is that they will have to go and queue behind the first person, and if that person has to make like 3 withdrawals, maybe the person wants to withdraw like 60,000 naira, the person will have to make like 60 withdrawals to get his money out. After the person is done, then the next person will go and withdraw his money. So there is going to be a long queue. It's going to be cumbersome. So what we can do is to have a distributed network of ATMs, which is what banks have done. So they distribute the ATM network. So if all the money that people want to withdraw, if you aggregate everything together, it's like maybe 200 million in a day. All of that 200 million naira is shared between the ATM terminals. So people go with their card to different ATM terminals. So when you go to a particular ATM terminal, when you see somebody on this queue, you just leave. You leave that. When you see people on a queue, maybe 5 people, 6 people, you can decide to go to another bank where there are less people on the queue. That is the exact example of distributed computing, you know. So so that is the way distributed computing works. But again, when you look at that ATM network, is there an issue with it? Yes, there's an issue with it. That is why you hear the ATM will tell you, please wait while your transaction is processing. Please wait while your transaction is processing. If we aggregate all the please wait while your transaction is processing, if we add up all of those time together for all of the ATM transaction and all the ATM withdrawal that is done in a day, in a year, can you imagine how much time is lost? Please, I want to know if I'm the only one on the call or if there are other people on the call with me. Yes, there are other people on the call with me. Does it make sense what I'm saying? Hello?
Yes,
Okay,
it makes sense.
okay, thank you. So when the ATM is giving feedback that please wait while transaction is processing, that feedback is latency. So it's like a wait time. The same thing also applies in distributed computing network. So while a job is being executed, you know, other jobs that are also waiting for that resource, they will also have to like wait for the job that's currently in execution to be done before they can take a space maybe on the processor or on the memory. So now the question is that is it now possible for us to solve the problem of please wait while your transaction is processing? Yes, if you think about it. And why that is happening is that the ATM itself, it's communicating, it's trying to communicate with the Finacle, with the core banking application somewhere, you know. So the core banking application is the storage, you know, It has information about the bank account of the person that wants to withdraw money, the balance that the person has in his account. The ATM itself does not have information about the amount the person that wants to withdraw, the amount the person has in his balance. The ATM does not have that information. So ATM has to communicate with a backend system to get that information. So by the time the backend system sends a reply back, that is when the ATM can now proceed to issue the command that money should be released to you. Now, assuming that the ATM has a memory of your account balance, you know, if the ATM has a knowledge of your account balance, the ATM will not need to communicate with the backend system. That means that the ATM will be able to process your money a lot faster than how it would ordinarily process the money. So appreciate computing. That is exactly how that's how computing works. So most of the time we try to solve the problem of speed and we try to solve the problem of waiting, you know, that problem is called the problem of latency. So latency is just the delay. It's the aggregate delay between all the system, between when a job is done and when the result is out. So So in spite of all this technological advancement, all this concept of Hadoop technology, distributed computing, parallel computing, there is still the problem of latency, which is the aggregate delay due to individual tasks involving huge amount of data or involving huge amount of processes. So, and when you think about big data, of course, because big data will require some time for its own execution, that will require some minutes of or some seconds of wait time. So when you add all of that together, it becomes what we call as latency. That affects the performance of your job. You know, when you're executing some job, it will bring delay to your job because your job is actually processing. While your job is processing, you have to wait. And every other person that also needs the same resources with you will have to wait. So that lowers the performance of your job. So in order to handle this, some of those things that they have done is to now combine parallel processing and distributed processing in a way that the physical infrastructure itself would have some level of memory, you know. So let's go back to our ATM example. And as I said, assuming that ATM does not have to connect to your bank, you know, to go and check your account balance, assuming that the ATM knows what your account balance is at the point you want to withdraw, then it means that the ATM is just going to issue you money. And then it means that the ATM processing is going to be a lot faster than it having to say, please wait while the transaction is processing. Yeah, so that is one way that can be solved. And that is one way it is solved. And one solution or one application or software that helps to solve that problem is the Hadoop technology, which we are going to be talking about in any moment from now. So the combination of distributed computing and parallel computing technique, it's a way of helping to reduce the time of processing of jobs. So it means that each of those ATM terminals, for our example, will also have their own memory. They also have their own storage capability, so they can hold information about each entity that is withdrawing money from that terminal. I think for people that have a lot of IT background in the house will be able to relate with some of this a lot more, because it's actually like it's something that is seen every day for the guys that work in server rooms. Any questions before I proceed? Any question, please, before I proceed?
No, sir.
Okay, so thank you very much. Okay, so this diagram is just trying to show how the concept of distributed computing works for big data. So for instance, there's an external data that is coming. There's a job that is coming, and the use from an external source. There's a job that's coming from an external source, and a user invokes that job. You know, it's a big data job, and the job is split into different tasks. It's split into different tasks, and each of these tasks is assigned to a particular node. I'm using some big words now. Node, yeah, it's assigned to a particular node. A node, it's like so let me show you what a node is. This is a node. So this a processor, a unit of processor and memory. It's like a computer. It's like a node. So this is a node. This is a node. This is another node. This is another node. So this is like a 4-node. This is like a 4-node distributed system. Why this is just a single node. This is a single node. The parallel system in this diagram is a single node. Why this distributed system network has 4 nodes connected in it. So so in this diagram, this is like a cluster. This rack here, this long computer is like a rack. It's like a rack that has multiple nodes connected together in it. So the job is each of the tasks is assigned to different nodes within the cluster, and the result is combined together and returned back to this. So when yesterday I did an example, I searched for the word food. I searched for the word food and it returned back 8.6 billion responses within 0.64 seconds. The question is that, is this 8.6 billion responses, is it coming from one single computer? No, it's not coming from one single computer. It's coming from clusters. It's coming from multiple computers. It's coming from multiple computers. Yesterday it was Iya Blessing. Today is Iya Sulaiman that is coming out. So it's coming from multiple computers, and the result is combined together and is presented to you. What is happening in that? What is happening in that space? It's a job. A user invokes a job. That job is a big job, because if the number of responses I'm actually interested in is 8.6 billion responses, one single computer cannot get that out in 0.6 seconds. So the job has to be distributed. So the job is spread to all the computers that are available globally, and the result is returned and is combined together and is displayed on the screen, and I can see the result, and then I can now browse and navigate to which of the responses I'm interested in. That is what is happening behind the scene in computing. And again, as I said, it was Yahoo and Google that developed this concept of distributed computing. And because it has worked for them for a very long time, so they decided to make it open source and release it to the public. So today, you too can now set up within your own company or within an establishment. You can also set up a distributed computing system within your environment. Okay, so that is that on distributed computing. Let's spend some time to look at parallel computing and how parallel computing, how it works. Again, this diagram comes in handy. So in parallel computing, it consists of independent processors that are sharing common memory. That's how parallel system, that's how they work. And the idea about it is so if there is latency, if we say that in distributed system that there is latency, because it takes a while for the job to execute. So which means that if we increase the processing power of each of these nodes, if I increase the processing power of each of these nodes in a distributed system, that means I'll be able to execute the job a lot faster. So at least I'll be able to reduce the time. So if it will take maybe 3 seconds for only this computer to execute the job, perhaps with 3 processors, maybe I'll be able to execute it in 1 second. So that means I have saved 2 seconds. And when you aggregate all of those 2 seconds, when you aggregate it together for a very long time, you will say that you are really saving a whole lot of time, So, so let's go to distributed computing. And this table is trying to show the techniques that are involved in parallel computing, and some of these techniques are available today for when you have to deal with large volume of data or data that is changing very fast. If you can, please cast your mind to companies like MTN, companies like banks, Zenith Bank, First Bank, FCMB, and the rest of them. These are entities that actually they have huge customer bases. They generate a lot of transactions. Even in the middle of the night while we are sleeping, people are generating transactions. Even when people are not generating transactions, the transactions that they have generated, they are reorganizing themselves on the system so that the system can be more available to users. So parallel computing techniques actually involve some key concepts that we want to look at. Number one is what they call grid and clusters. Grid and clusters. So in parallel computing, when you have a number of servers, or a number of parallel computers that are connected to a network, that is called like a cluster. So you can have like a 2-node cluster, 3-node cluster, 4-node cluster. If you look at Google is actually like a grid, the way Google it's like a grid. That's why you can have google.ng, you have google.com.ng, you have google.com.india, you have google.com. Many different countries. So if each of these, so let me quickly show you this .in. .in means .com.ng. .com.ng means .nigeria. Let's say google.co.in. google.co.in is India. google.co.uk. google.co.uk is UK. Each of these addresses actually represents one computer, and all of these computers, they are connected together in what now forms like a grid of interconnected computers, and the grid is usually very cost-effective way for managing big data. So instead of only one system to get the job done, multiple systems are going to be doing it, and they're going to be doing it in a way that is transparent to every other person. Then there is also the concept of massive parallel processing. These are also some computing techniques. So the MPP platform is like a single machine that works like a grid. So we can also probably have, let me go back to this diagram. So we can also have this kind of server, for instance. So imagine you have like maybe 20 processors. You have 20 processors in this. In a case where you have 20 processors and you have more than one single memory, but it's just one computer. They are not interconnected like the way you have in tech computing. It's also the concept of parallel processing. And the idea again is, how can we make our job run faster? If we increase the processor, will it run faster? If we increase the memory, will it run faster? So that is the whole idea. So in parallel, in massive parallel processing, the way it works is that it's like a single platform that works like a grid. But it's a single machine that has its own storage, its own memory, and also runs its own computing tasks, Then the MPP platform is always very good for some kind of job. It's always very good for virtualization, and we are going to get to talk about virtualization very, very soon. Then the third concept of parallel computing is what is called high performance computing. So I like this diagram. I'll have to go back to the diagram again. So if you look at this diagram, between this, for all of these nodes, this is a node, this is another node. There are 4 nodes under this disparate system. There is only one node under parallel system. Now, for each of these, there is always a back and forth between the processor and the memory. That back and forth between the processor and the memory is also responsible for the latency problem that we identified earlier on. So they also came up with a concept why they thought that is it possible to have a memory within the processor. So if we have memory inside the processor, so the back and forth between the memory and the processor can be significantly reduced. So that led to another concept that turned out to be a high performance computing how do I put that now? That led to what is now referred to as high performance computing, where they use in-memory technology and where the concept of in-memory technology is used to derive faster processing of job and faster execution of job. So the idea, as I said, is we want to limit the time, because we also, when we aggregate all the back and forth between processor and memory, it takes a lot of time when you accumulate all of it together, because we are dealing with big data. So why not now implement the memory within the processor so that we can reduce the back and forth that is in there. Okay, so there's a small girl that is disturbing me around here. I've sent her away. Do you have a question, caller?
Yes.
Please go on.
Okay, now for the MPP, you said
Yes.
it has more than one memory.
Yes.
So and then does it still mean that it is still one single node?
It's still a single node. It's still a single node. It's still a single.
Does it
Go on,
look
please.
like?
Okay,
How
hold
does
on.
it look?
Even your computer, if you buy a, say you just buy a small laptop, for instance, a laptop, that laptop will probably come with 8 GB, 8 GB RAM. You understand? So you can now go and say, oh, I want to increase the memory of my PC. You go to Computer Village and buy another 8 GB RAM. There's another slot. It's still the same computer. So you see the same computer, there's another slot. You insert that memory into that second slot. Now your memory goes from 8 to 16, but it's still the same computer, unlike in the display system where each of them, they are independent.
Okay.
Does it make sense? Or you want to ask it in a different way?
Yeah, I think it's fine. They still make use of the same processor rather than the distributed where it has different memory and different processor for each node.
So exactly. So and for high performance computing, the memory is inside the processor. So it's not going to be like that kind of a system where you can say, I want to go and buy memory and slot in a new memory. The memory for high performance computing, that memory is built into the processor itself, and that will allow for a lot of speed. One of those problems we try to solve in computing is speed. That is the time of execution of tasks and how much space is available. Those are some of the problems we try to solve most of the time. Okay, so all of this take us to another concept of big data again, and that concept is called the concept of virtualization.
Sorry, excuse me, sir.
Please go on.
The memory now in the HPC, can it be
Yeah.
like a cache? Can we call it like a cache? Is it the
No, it's
same
not cache.
concept?
It's not what you normally call cache. It's not cache. So it's the concept of that cache. Cache is usually very small. Cache is usually very small. It just holds things temporarily. Something that it's something that you reference again and again and again. Yeah, so it's like a small memory that will just hold it for a very short period of time. So cache itself does not execute, it does not execute the job. Memory is involved in the execution of the job. So when you now take that memory that is involved in the execution of the job, you now etch it into the processor itself, and you are getting the job executed right in there inside the processor. Then that is in memory computing. It's more advanced than the cache technique. Does that explain does that clarify your question, Mary?
Yes, I get you.
Okay, so all right, so that takes us to the concept of virtualization, and I'll give you an example. So we did a project with NIBS sometime in around this time last year. That project ended around this time last year. So the project we did with NIBS, we had, so we were supposed to buy 3 servers. So when we bought one, we bought the first server to buy the second, the other 2 later on. But when we bought the first server, when we got to NIBS said that, see guys, this server that you have brought, we don't have any space for that server in our office. We don't have space for this server in our office. That go and buy one single server that will have the capacity of the 3 servers that you would need for your project. Although some of those servers, they are not usually off the shelf, so the guys in Computer Village or the guys in that line of business can build that server for you. So what we did was to now buy a single server that has a capacity of 3 servers. And when you want to go and buy a computer, there are some things that you normally ask for. Okay, I want to buy a computer. This is the RAM size that you want. You can say you want 8 gig RAM. You can say you want 8 gig RAM, maybe 1 terabyte hard disk drive, and then maybe 2.2 maybe 2 gigahertz. It can be 2 gigahertz, for instance. That is the processor speed. Now, so what we had to do was that we bought like 1 server that has the capacity of the 3 servers that we require. Now, there is now what they call VMware, virtual machine, that will be installed on that 1 single server and then partition that 1 single server into 3 different servers. So, so that concept is called the concept of virtualization. And it's also trying to cut costs, and it's trying to maximize the resources, the physical resources that is available. So the concept of virtualization tries to isolate the available resources and services from what I call the underlying physical environment. We also have that in some of our projects that we are currently doing. In all the projects that we are doing, FCMB, for instance, for those of us that work in Octave Analytics, FCMB, eTransat, Coronation, all of them, in all of those is virtual servers they give to us. So if you go to a computer, so at some point you see that our disk space can easily get filled up because we are not the only one that is using that virtual server. There are other people that are also sharing that server with us. So the way it is that we cannot go and buy 20 computers. Octave Analytics is having a project, and FCMB is having another project. And for Octave Analytics project, they need 3 servers. For this other project, they need 7 servers. So if you go and always be buying server and be putting them in our server room, this place will be filled up with physical infrastructure. That means we need more physical infrastructure. So is there a way we can go about it? So we can have 1 single computer. We can build a computer that have the capacity of 3 computers. And then we now use a virtual machine or use the concept of virtualization to partition that 1 single supercomputer, in quotes now, that single supercomputer into smaller units that will also act as a single node, as independent computer by themselves. That is one thing that is part of our everyday life. So for those of you that even connect to some of those servers, you think that you are connecting to, when you connect to something like it, maybe the visualization server, and you connect to the maybe ADS, and you connect to the storage, to the staging server, you might think that you are connecting to 3 different physical servers. No, in real sense, you may actually be connecting to only 1 physical environment that is virtualized. So virtualization tries to separate resources and services from the underlying physical environment by allowing you to create what is called virtual systems on a single physical environment. And I think that is quite clear. So it's like you having, so some of you guys, you also do it. One way you do that is you can have a virtual machine on your own computer, for instance. So on the computer you are using to stream in this class now, you can install a VMware on it, and on that VMware you install Linux. You can install Linux on it. Yeah. I don't know if you guys have also, it's even part of what comes with the e-lab that comes for the DASCA class. I don't know how many people in this class have installed the e-lab. That e-lab comes with a virtual machine that you install on your computer, and you can install like multiple virtual machines on your computer, and you run them, and all of them, they are going to be running as if there are multiple independent computers that are running on your computer. But in the reason, they are running from 1 physical infrastructure, but they appear out there as maybe multiple computers to the people that are connecting or that need to like send jobs to those computers. So this is one concept that is very, very relevant. Okay, Kola, please ask your question.
Okay, so in our own case, because I'm aware in some cases when we have access to one server and then we don't have access to the other servers, and then we would have to restart one server for the other. But from what you said now, you said it's possible we're connecting just to one single server. So
Yes.
I'm confused there somehow.
Okay, so yes. So when you restart, what you are restarting is not the physical computer. What you are restarting is not the physical computer. What you are restarting is the virtual machine that is on the physical computer. So you understand? So it's when you restart, the machine that you are restarting is not the physical hardware itself, but it's a virtual computer that is on a physical hardware. You know, you can demonstrate that. So if you have the virtual lab that came with this DASCA e-lab, you know, if you have that virtual material, it's a process you have to go. And I think I need to spend time to guide you. For people who have not installed that, I need to guide you on how to do that installation. So you download the material from the web. We have downloaded it in the office, so you can come with an external hard drive and copy it to your own personal computer. Then there's a virtual machine that you need to install on your computer. That virtual machine can activate multiple virtual computers. So one of those virtual computers is a Linux, is an Ubuntu environment that you start on the virtual machine. So if you start that Ubuntu environment on a virtual machine, if you start that Ubuntu environment on your physical computer, you know, you can even install you can install Oracle on it, and then you can connect to that Oracle system and you are querying it. But you are not querying your physical computer, you are querying another computer that is on top of your computer. And if you shut down, if anything is wrong with that virtual machine, you don't necessarily need to shut down your own physical computer. A case where it will affect all of those computers, is if anything affects the physical computer, then it will need to affect the three servers together. But if it's not affecting the physical computer, if it's only affecting one of the virtual computers, anything can be wrong with the virtual computer. So without necessarily affecting the other computers that are connected to the same virtual machine. So you can just restart it and then it will be working. Does that answer your question?
Yeah, fine, sir. Thank you.
Thank you for making it interactive. Really, these are part of what we see every day, but at times maybe we cannot relate with it because maybe we've not had some issue. But really, virtualization is even what you can do by yourself on your computer. There's a virtual machine that comes with the e-lab. So we can probably demonstrate it maybe in the next class. I'll just find a way of demonstrating that in the next class if you remind me. So this helps to, the idea is also to solve the big data problem, because when we need to work with a lot of data, we need a lot of memory and a lot of space. So the big data challenge typically requires management of large volume of data that are distributed within different storage. So what virtualization provides, it adds another level of efficiency, you know, to make big data execution a reality, and to reduce some kind of latency that could come with managing big data. Although you can execute big data, or you can analyze big data without working in a virtualization environment, you know, but it only makes it more efficient. You know, it only makes it more efficient. Does not mean that it must be a requirement. So as I said, they can also say that, okay, no, we are not working with virtual servers in wherever project that we are working on. They can say, okay, physical server, the ADS is on a different server, the staging server is on a different server, visualization server is on a different server, and they are all connected together. You know, they are not sharing the same physical resources. That can also be done. But virtualization helps you to even save cost. It helps you to save cost. It helps you to save the physical space that is available. You know, it helps you to manage things, to share resources better. Because at times when you also have those individual physical servers, at times it's not all of them that is working at the same time. In some cases, some of them may just sit down there and be redundant. But when you virtualize it, it means that other people that also have things that they have to do can share that physical server and do their work independent of your own work, you know. Some of the features of virtualization, some of the features of virtualization include what they call encapsulation, isolation, and partitioning. Of course, you can relate with partitioning because what makes virtualization, what makes it to work is that a physical server can now be partitioned into three or four servers, you know. So partitioning is a feature of virtualization. The next one is isolation. So each of those partitions, they are isolated from the other one. So if Mr. A, caller said that he had to restart a server, you know, because that server is isolated, even though it's on the same physical infrastructure, it's isolated from other virtual servers that are on that same physical infrastructure. So when he restarted it, he did not have to restart all the other servers. He did not have to call people, guys, I want to restart my server now. He didn't have to call them because it's isolated from the rest of them. And there's encapsulation. Encapsulation means capsule, you know. In a capsule, you can wrap something inside a capsule, and then what is outside, you don't know what is outside it. It's encapsulation is a big word. I wish I can explain it in a very non-technical way. So encapsulate means, okay, look at the capsule. In a capsule, there is a lot of the real active ingredient in the capsule. In a drug, that's a capsule. It's not visible to you, you know, but you just see a capsule and then you drop it in your mouth. I wish I can explain it better. I know I didn't do a good job in that one. But yeah, encapsulation tries to like group a lot of things together into like a single server, and it's kept away from every other stuff. I think I didn't explain that very well. I'll try maybe later on to explain that very well if it comes up again. So and as users begin to leverage, so the concept of the next thing we are going to be talking about now is the concept of Hadoop technology, MapReduce, which are also part of the technologies for handling big data. So this concept, what they leverage all of these technologies that we have talked about. They leverage distributed computing, they leverage parallel computing, they leverage visualization in order to get job executed very, 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 very fast. So I think when we start talking about them, you'll be able to also make sense out of them, you know. And for me, when I also explain some of these things, I try to relate it to everyday life, things like ATM machine, you know, you'll be able to make sense out of it if you can picture what these technologies, how they relate to everyday life or for what we do every day. And as users begin to leverage this environment for maybe MapReduce and Hadoop technology, it's also critical to know that it's supporting infrastructure, that is the physical infrastructure that is holding all of this technology. So the physical infrastructure can scale. So which means that I can come and in distributed computing, I can come and add another node. I can come and add another 4 nodes to this and take it from 4 nodes to 8 nodes. In parallel computing, I can come and add more processor to this system. You know, I can come and add more processor to this system. In visualization, I can add more virtual machine to the same physical environment. So what visualization tries to do is that it tries to add efficiency to all the physical IT layer that is available. And some of those efficiency is the physical space that is available, and even the cost that you have to incur. You know, if I have to buy 3 servers, I think one of those servers then that we bought around last year was maybe 1 million. So if we bought 3 servers, we would have bought those 3 servers for like 3 million naira. you know. But the big server that we bought that had the capacity of those 3 other servers, I think we bought it about maybe 2.3 million naira. So what happened is that we saved 700,000 naira, and then also the physical space that they occupied, the NIP server room, was much more less. Yeah. Thank you very much. So now let's go to the concept of Hadoop technology. For Hadoop is something that a lot of you must have heard again and again, you know, and then you'll be wondering how does it work? What is special thing about Hadoop itself? You know, yeah. So Hadoop is it's like a big data framework. It's an open source big data framework that is designed to support huge volume of data that is structured and unstructured. You know, Hadoop is best fit when the data is unstructured. So imagine, how do you organize, if I want to go to Twitter and gather everything that people have said on Mr. Mohamed Buhari in the past 4 years, I want to go and collect everything together. You know, Excel will not be able to hold it. And if I want to put it on Oracle database, how am I going to structure that on a table? Because that data is largely unstructured. Or imagine if I want to go and scrape all the pictures that they have posted on maybe an Instagram handle or Instagram page, and I want to analyze all of those pictures. They are unstructured data. How do I handle them? You know, so the traditional data management platform that you have, they fall short in managing big data. So because of that, they now came up with the concept of Hadoop technology. And as I said, it was originally designed by Yahoo, and then after a while they released it to the public and it became an open source technology. So it facilitates analysis of huge volume of data that probably were traditionally done using other kind of concept like maybe parallel computing or distributed computing technology. And what Hadoop does is that it tries to distribute the data efficiently across all the different nodes, you know. And it also explores the concept of parallel computing to distribute the data across all the different nodes that are within the distributed computing environment. So Hadoop works in like a cluster. So when you install Hadoop, if you install Oracle now, you can install Oracle on only one single computer. Or if you install Microsoft Office, you can only install Microsoft Office on one single computer, and that is where it's going to be, you know. But when you talk about Hadoop is best implemented on a distributed computing system, and it's a software that leverages the distributed computing technology, you know. So let me go back to this diagram and then use it to explain again. So look at this. So here, this is a distributed network of computers, for instance. So what if I now have a software that runs on this computer, that runs on this computer, that runs on this computer, that runs on this computer in a coordinated way, you know, in such a way that if I have a job that needs to be done by all of these computers, it is that software that manages the execution of that job, the partition of the job among the different computers, and the combination of the job back into a single result, you know, and then it's going to be able to determine which resources is available to execute a subunit of the tasks that I have assigned to this distributed network. That is the same thing that Hadoop is trying to do. It's a piece of software. It's not a hardware. More or less, what we've been talking about distributed computing, parallel computing, it's mainly about physical hardware. It's about the physical hardware. Virtualization is maybe how to manage the physical hardware in an efficient way. Now, what Hadoop does is that it introduces another level of efficient management of all these concepts altogether. And Hadoop now introduces a simple programming model that lets users to create jobs and run the job within a distributed system. So, okay, any question before I proceed on Hadoop?